Explaining the conversion from mild cognitive impairment to Alzheimer's disease using Shapley value. As I assume everyone knows about Alzheimer's disease, I will only say there is no effective therapy to cure AD. We should identify patients at risk of converting from MCI to AD so that we can monitor subjects for therapy studies. Shapley values and SHAP. A prediction can be explained by assuming that each future value of the instance is a player in a game where the prediction is the payout. Shapley values, a method from coalitional game theory, tells us how to fairly distribute the payout among the features. The Shapley value of a feature value is its contribution to the payout, weighted and summed over all possible feature value combinations. The math behind is crazy. Three desirable properties are local accuracy, missingness, and consistency. And these are important properties for interpretability tools. Shapley values, a powerful explanation tool for ML models, is the main tool for the study. And here you can see a summary plot of my logistic regression model. My project's definition is that understanding a complex classification model with application of a future importance tool such as SHAP to gather information on how to detect the early phase of AD, pMCI patients, and explain the conversion from MCI to AD possibly. We will talk about my dataset, modeling, analysis, and evaluation. Data used in this work are obtained from a DNI database, and you can see my preprocesses for the data. Data has 3 labels, but we will not use MCI to AD. 14 features, 8 of cognitive and 6 MRI. Data is unbalanced, 5:2 ratio of MCI to AD. Data is temporal. I transformed the data to expand the dataset to the size 7 times. I used logistic regression and XGBoost, compared them. You can see that data seems like linearly separable from the 3D plots, but it's actually not linearly separable, so XGBoost performs better. XGBoost Shapley values are also more interesting and useful for than logistic regression models. Part of the study was coming up with some success criteria, identifying a great ratio of questionable diagnosis of the model using sum of all Shapley values and the most important features Shapley values of instances, and statistics was the success criteria at the end. I inspected and analyzed the Shapley values and graphs using several plotting functions of SHAP library to interpret the models. Then I analyzed the data and found out some thresholds of Shapley values to create some criteria for detecting questionable wrong diagnosis classifications so that I can explain the conversion from MCI to AD and find out a way to detect pMCI and early phase of AD patients. Here you can see the summary plot for XGBoost model. This is a force plot of the XGBoost model. Here you can see from -1 to 0.5 of Shapley value interval, the diagnosis can be suggested questionable. And in this interval, out of 43 AD patients, 24 were classified as MCI. And these could be suggested as early phase of AD patients. For example, out of 19 MCI patients with CDR-SB Shapley value greater than 0.5, 15 were predicted as AD. These cases can be suggested as pMCI patients that have high risk of converting to AD. And you can see here two waterfall plots of the 2 different models. Here you can see how much different they are from each other, like the scale of the Shapley values of instance features. Evaluating the success of the study is challenging as there is no ground truth labels. Using interpretability tools for ML is a great way to understand what a black box model hides from the engineer. We can suggest that we could use the information from Shapley values of a model to understand the conversion from MCI to AD, to detect a pMCI and early phase of AD patients without knowing the stable and progressive MCI or phases of AD ground truth labels. As you have seen from the results, this argument can be proven to some degree even if we had an unbalanced dataset. Thank you very much.